Standard 1.11. Identify a quadrant given the signs of a sine and cosine of an angle in that quadrant, or give the sign of the sine or cosine of an angle given its quadrant. All right, so let's take our coordinate plane and let's talk about the sign, S-I-G-N, of sine and cosine in each quadrant. Now in quadrant number 1, we know that our x-coordinate is positive, our y-coordinate is positive, and r is positive. And if we talk about sine, the sine of theta, which is y over r, is positive divided by positive, and therefore the sine of theta is positive. And similarly, we can analyze the cosine of theta. Cosine of theta is defined as x over r, both of which are positive. Positive divided by positive is positive. So sine is positive and cosine is positive in quadrant 1. Moving to our next quadrant, in quadrant 2, we can do the same type of analysis. The x-coordinate's positive, the y-coordinate, I take that back. The x-coordinate is negative, the y-coordinate is positive, and r is always positive. And now if we think about the sine of theta, which is y over r, it's a positive divided by a positive, which is positive. And the cosine of theta is a negative divided by a positive, which is negative. So in quadrant 2, sine is positive, but cosine is negative. We can do the same thing for quadrant 3. In quadrant 3, the x is negative, y is negative, and r is positive as always. And to find sine of theta, we do y divided by r, which is a negative divided by a positive, which is negative. And cosine of theta is x divided by r, which is negative divided by a positive, which is negative. So both sine and cosine are negative in quadrant 3. And in quadrant 4, x is positive, y is negative, r is always positive, and the sine of theta, which is y over r, is negative divided by positive, which is negative, and cosine theta, which is x divided by r, is positive divided by positive, which is positive. Note that the top half of the graph, sine is positive, and in the bottom half, sine is negative, and that's because sine is basically dependent on the y variable. Notice on the right side of the graph, cosine is positive, and on the left side of the graph, cosine is negative, and that's because cosine is basically dependent on the x variable. All right, now suppose that you are asked if the sine or cosine of an angle is positive or negative. So let's take a look at the sine of 310-degree angle. We want to locate where the terminal ray is. So for a 310-degree angle, the terminal ray is located in quadrant 4. In quadrant 4, sine of theta is negative. Sine is dependent on y, and the y variable is negative in that quadrant. Let's find the cosine of 310 degrees and decide if it's positive or negative. Actually, we're not finding it, we're deciding whether it's positive or negative. So in quadrant 4, 310 degrees, cosine of theta is positive, and that's because in quadrant 4, x is positive, and so cosine is positive. Let's do one more angle measure. So let's find out what's happening to the sine and cosine of, let's do negative 240 degrees. So starting with sine of negative 240, if we sketch a graph of that angle, it's negative, so we'll be going around in the clockwise direction. It terminates in quadrant 2. In quadrant 2, sine is positive, And that's because your y-coordinate is positive. And if we take the same angle, but find the cosine of negative 240 degrees, the cosine of this angle is negative, and that's because the x-coordinate of this angle is negative. So it doesn't depend on whether the angle itself is positive or negative. What it depends on is where the terminal ray is located. If it's located on the top half of your graph, sine is positive. If it's located on the bottom half, sine is negative. If it's located on the right side, cosine is positive. If it's located on the left side, cosine is negative. Think about associating sine with the y-coordinate and cosine with the x-coordinate. This was standard 1.11, determining the sign, S-I-G-N, of sine and cosine in each quadrant.